Hello my dear children, this is class 11th, third chapter is going on. Already I have given you MCQ tips of 2 chapters. One is structure of atom and second is some basic concept of chemistry. So after that we will start with also solving MCQ questions within days. Now this is the third lecture regarding MCQ tips only. MCQ tips of chapter periodic table. Listen to this video carefully and also make the notes along with me. So I'm going to start modern periodic table first. Modern periodic table. It's not Mendeleev, it's not Dobrynier, Newland. I'm going to start with the new syllabus of 2020, that is modern periodic table. Modern periodic table was invented by scientist Moseley, right? Moseley. The basis of this table was atomic number. Whatever I am writing, kindly note down each and everything. And Moseley performed experiment, that is nu, under root nu proportional to atomic number. Nu is the frequency of the X-rays. Nu proportional to Z is the atomic number. It was a Moseley experiment. The experiment detail I have covered in my chapter periodic table, where I have taken detail-wise study of each topic. Now dear children, in this table, in this modern periodic table, you all know there are 18 vertical columns, that is 18 groups. There are 7 horizontal rows, that is periods. There are 4 blocks, S, P, D, F. There are 4 blocks, it is all about. Now I'm taking like that. Periodic table, Moseley, atomic number based, under mu proportional to Z experiment, 18 vertical columns, 18 vertical columns and 7 horizontal rows and 4 blocks. These are the SPDF 4 blocks. Now I'm taking that periodic table a little bit. This is your S block. S block. In the S block there are the 2 groups. Group number 1 and 2. This is hydrogen. Hydrogen lies in period 1. This is your second period with lithium, beryllium. This is your third period. This is sodium, magnesium. Fourth period. Potassium, calcium. Fifth period. It is your radium, cesium. Radium, strontium. Sixth period. It is cesium and barium. Seventh period. It is your francium and radium. So this is your periodic table. S block, it is right. It is an S block having all our metals. The most metallic, the most electropositive metals write down lies in group 1. The name of this group is alkali metals. This is your group 1. In older time it was called 1A. In your second group it is 2A. 1A, 2A. So it's alkali metal and this is called alkaline earth metals. Alkaline earth metals. So these are all called representative elements. These are called representative elements. Kindly note down each and everything. Within half an hour I will complete the chapter periodic table MCQ tips. That will be great helpful in solving the MCQ questions. This is your alkali metals group 1. This is group 2 alkaline earth metal, S block, representative elements. Now this side, there is a P block. P block and S block are the terminals. This is P block. In the P block there are 6 vertical columns, 1, 2, 3, 4, 5 and 6. Now this is helium. Helium lies in the first period. This is called group 0. This is called group 18. This is group 0 because its valency of this is 0, helium. This is your second period. This is your second period. Having it is your boron, carbon, nitrogen, oxygen, fluorine, anion. Kindly note down the second period is a period where there is a maximum elements are gases. Nitrogen, oxygen, fluorine, neon, gases. Second period contain maximum element in the gas phase. Okay, there are 11 gas and 6 liquids. After rest are solids. Next is aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Note down this is the period, third period, where the elements are called typical element. Aluminium, silicon, phosphorus, sulfur, chlorine. Each and everything can note down. These are called typical metals. These are typical elements. Typical. After that, this is your next third. This is your fourth period going on. Again, it is a fifth, sixth, and seventh. So this is yours 1. This is your second, third, 4, 5, 6, and 7. Elements names are already I have shared with you in my lectures. So it is gallium, germanium, arsenic, selenium, bromine, and krypton. This is group 17, 7A. This is group 16, 13, 14, 15. This is 3A. It is 4A, 5A, 6A, 7A. And in between S and P block there is present, this is your here in the fourth period started D block. In the fourth period, it's a D block. Fourth period. Okay, so this is your all. This is your 3D series, 4D series, 5D series, and 6D series. Okay, now what is this? This is your element. First 10 elements lies here. It is your 19, 20, from 21 to 30, atomic number 30. After that, it is your 36, 37, 38, and it is your 39. You add 10 more, you will add 10 more, it is your 48, 9, 50, 51, 52, 53, 54. This is all. Started from scandium, end up to zinc, 10 elements in each series. It is your yttrium, while end up to cadmium. It is your lanthanum, end up to lanthanum, end up to lanthanum. It is your 2 starter element, and lanthanum, hafnium, and end up to mercury. Now this is all about. After that there is a titanium, and from this IUPAC name will continue that I will tell you. So this is your D block. This is your P block. D block elements are called transition elements. S and P block are called representative elements. Representative elements. And there is a 10 element each. Now kindly note down, this is a group third. This is a group number 3, or it is your, this is a group, dear children, where the group in which there is a maximum number of elements, because 14 lanthanum and actinium, you know this is all about 57, lanthanum atomic number 57, and actinium is your, it is 89. You know from 57 and no entry on the D block, 58 will come here, and 14 element will come here, 71. And after that again 89, 90 will come here, plus 14 element, it is your 103, and it is your 104. This is 4F series, and this is 5s. Detail, kindly check the detail of each and every group in my vast lectures where I am explaining each and every point. So this is a product table, just few things I wanted to share so that you may easily find what is the actual answer of the following MCQ. Now kindly note down, every element follow the magic number 2, 8, 8, 18, 18, 32. 2, 8, 8, how they follow? Let it is your 1, now you add 2. It is your 3, now you add 8. It is 11, add 8. It is 19, add now, because you're at 18, it is 37, add one more 18, 55, add 32, it is your 87, 32. Now this is the way you can find the atomic number of any of the element. Now same, it is 21, 21 plus 18, it is 39, 39 plus 18, and after that 32. This magic number will go in a group 288. Same way that beryllium is 4, you add 8, 12, you add 8, 20, you add 2 times when you added it, or start at 18, now it is your 38, start 18, same way, then 32. So in this way you can find the atomic number of any of the element. If you know one of the atomic number of any of the group, then other atomic number can easily be calculated by applying this formula. This is a magic number 2, 8, 8, 18, 18, 32. So again listen, it is your 1s, it is your 2s, 3s, 4s, 5s, 6s and 7s, but there is no 1p. It is again 1s, drawback of periodic table. It is 2p, 3p, 4p, 5p, 6p and 7p. But the D block lie one behind. It is your 4th period, it's a 3D series. 5th period, 4D series. 6th period, 5D series. 7th period, 6D series. Now kindly see, it is a 6th period, but it's a 4F. F lie 2 behind, anti-penultimate. 7th period, it's a 5F series. So this is a third group which has a maximum number of element, because this here plus 14 will be, and here also plus 14 will come. Now you may write few points from the modern periodic table. Right, and the first point you may write is how many gaseous elements are there. Right, gaseous elements, total gaseous elements are 11, total liquid elements are 6. Third point you may write maximum element which are present in the gases in the second period. Typical elements are found in the third period. Maximum elements found in the third group, and neptunium and plutonium. These two are the elements named based on the planets. Neptunium and plutonium are the two elements whose names are given based on the planets. First man-made element is technetium. You may write please. First man-made element is technetium. First man-made up to 92. Here 91, 92. 92 is uranium. Up to 92 all elements are natural, and after 92 elements are transuranium. Right, transuranium. Transuranium elements are those which are present after uranium. After 92, those elements are present after atomic number 92. They are called transuranium element, and they are radioactive. Right, they are prepared synthetically, that is they are man-made. But up to 92 all elements are natural. Most electropositive metals found in group 1, most electronegative element found in group 17. Most electronegative element found in group 17. Most of the gases are found, that's found in group 0. Group 0, that is 18 group, is a group which contain all the gases, that is called noble gases or inert gases. Group 16 is called chalcogen. I think I shared everything with you. Group 15 is called nicogen. 15, nitrogen group. P and ICO gens, chalcogens and nicogens. So transition element F block are called inert transition elements. Now this is all what I am taking. This is a basic of your modern periodic table. Now I am taking few of the few of this questions from this topic. This is the first topic, modern periodic table. Write few of the questions based on this modern periodic table. Write down question number 1. 1s2, 2s2, 2p2. 1s2, question number 1. 1s2, 2s2, 2p2. 1s2, 2s2, 2p5. 1s2, 2s2, 2p5. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, and none of the above. The question is, out of these four, which belongs to alkali metal family? You know, alkali metal is a group 1. So group 1 is S1. So the correct answer is C part, alkali metal family. Right on the second question is, your second question is, which of the following set of the atomic number represent representative element? Representative, you know, S and P block are representative. Let me write the set: 5, 13, 30, 53. 5, 13, 30, 53. Second set is 11, 33. 11, 33. And it is your 58, 84. Third set is 5, 17. Which set is representative? 31, 54. And fourth set is 9, 31, 9, 31, 53, 53, and 83. Which set is representative set? You know what is representative? The elements belongs to either S block or P block. This is 1 point. Another, you must check the set must differ by 2, 8, 8, 18, 18, 32. You can check this set. 5 plus 8, it is your 13, and 13 plus, after that there is no digit and to give 30. This is not go with 2, 8, 8. Same, it is 11 plus 8, 11 plus 18, 11 plus 32. No, it is 5 plus 8, again it is no, it is 9. I'm taking these elements. Now you can take 9, 31, 53, 83. What you will check, these are all elements of the, because noble gas, you know, there are the noble gases. Helium, you will identify like this: helium 2, neon 10, argon 18, krypton 36, xenon 54, and radon 86. Now you may check the elements which are very near. This is noble gas, 54. And this is what? This is your halogen, because this is group 18 and this is group 17. So this element belongs to group 17. After that you can check radon is 86, it is group 18, 85, group 17, 84, group 16, and 83, group 15. So this elements belongs to group 15. Again representative 31. Or you can say krypton 36. If krypton is 36 is noble gas, this means it is your group 13. 13 it is. 31 it lies, because 31 started, 36 end up. After that it's 9. Again it's 9. It is near to the noble gas. It is group 17. So these are the elements which are of P block and they are representative. So you can follow this pattern. You write the noble gases. You know the noble gases, the family, the S block family is, your S block family is just 1 atomic number belongs to that. After that 3, after that 1 plus 2, 3, 3 plus 8, 11, 11 plus 8 is 19, 19 plus 18 plus 55 and plus 87. These are all elements of the S block. 3, 4, 11, 12, 19, 20, 38, 56 and 88. These are the atomic number of the S block, and those belongs to the P block. It is atomic number 2 and it started from, because noble gas is 10. So what is this? It started from 5, 6, 7, 8, 9. Atomic number 5 to 10. You write atomic number 2, atomic number 5 to 10. You know, boron is 5. After that, it is your argon comes, argon 18, it is your 13 to 18, atomic number 13 to 18. After that, you write these are all P block elements, and after that there is a noble gas is 36, and you pay 36. 36 means it is your, after that you can 5 plus 8, 13, 13 plus 18. I think it will be 5, it is 2 2 plus this 8, 5 plus 8, 13, and then you can do 13 plus 18, it become 31. After that, again it is plus 18, it is your 9 and 49, 54. After that, again 32, you may add 32, now 32, and 32 added, it become 86, and it become 70, it become your 81 to 86. So these are all elements belongs to P block. You may learn like this I as well. Either you adopt this pattern or you adopt your last noble guess, 2, 10, 18, 36, 54, 86. So 5 to 10, 13 to 18, 31 to 36, 49 to 54, 81 to 86. These are all elements of the S block and P block. And D block I already shared, it is your 21 to 30 D block. After that 39 started from, because 37 to 38, 39 to 48 D block. It is a 3D series and it is 4D series. After that, you know, there is what comes, there is a F block comes. So this series started from 57, and after 57 then there is a 14 element goes to the F block, and after that they will come, because your F block started from 58 to 71, and that comes 72. 72 will come here, 57, 72. Now you may add 8 more, that is 80. That belongs to your 5D series. After that there is a AC, actinium, 89, and from 90 to 103 will come here. After that there is a 104 to at the end. You may add 8 more, that's 112. 113 to 118 goes to your P block. I think it is clear. Or you may write now in a very that is easy way. S block, atomic number 1, 3, 4, 11, 12, 19, 20, 37, 38, 55, 56, 87, 88. This is S block. And what P block? P block is 2, 5 to 10, 30 to 18, 31 to 36, 49 to 54, 81 to 86. One more we add, 113 to 118. 113 to 118. And about 3D series, the 21 to 30 4D series, 39 to 48 5D series has 2 starter, lanthanum, halfmonium, 57, 72 and up to 80. Next is your that is your 6D series, 2 starters, 89, 104 and up to 112. And after that F block, 4F and 5F series. 4F started 58 and up to 71, and started 90 and up to 103. Kindly note down the starter and the last as given. It started as cerium, Ce. F block started as cerium and up to Lu, lutetium. Lu, lutetium. It started as thorium, Th, thorium, and down to Lawrence, Lr, Lawrencium. So this is your second question. I have solved by taking some in a very detailed way again. So we have covered modern periodic table, children. It is your representative element, transition element, D block, inner transition elements, F block, and write down the configuration one. I'm taking 1, 2, 3 questions more from modern table. NS 1 to 2 is S block. NS2, NP 1 to 6 is P block. NS2, N-1, D 1 to 10 is D block, 1 lies behind. NS2, N-1, D 0 to 1, N-2, F 1 to 14 is P block. So this is all about your S block, P block, D block, F block, general configuration as well. Now I'm taking your more questions from modern periodic table. We have covered 2 questions from modern periodic table. Third is, which of the following electronic configuration does not belongs to the same block? Write down third question. Which of the following does not belongs to the same block? Write down. It is xenon. It is 4F14, 5D10, 6S2. 4F14, 5D10, 6S2. Second is krypton. It is krypton. It is 4D10, 5S2. Third is your krypton again. It is krypton, 5S2. The fourth is argon, 3D6, 4S2. It is your argon, 3D6, 4S2. So the question is, which of the following electronic configuration does not belongs to the same block? Dear children, you know this is the first configuration which belongs to which block, because your 4F14 completed, this is your 5D10 completed. This is first we have filled this, then we have filled this. You know the electronic configuration, how to fill. First we fill 6S, then we fill 4F, after that 5D10. So this is the element which belongs to which block? It is your D block. Write down. It is your D block. And here again it is of D block, because after filling 5S is a turn of 4D, but it is belongs to the S block, and it is again of the D block. D block. This means you have three of the configuration of the D block and one of the configuration of the S block. The right answer is, if you don't know, again I'm telling you how to find it's a D block or S block. You know, whenever you start filling electron, you make a picture of the periodic table. First is the filling of the S block. That means if it is, you can see this 4F14, 5D10, 6S2. In this case, what we have done, we have filled, it is written outside, no, we have filled first 6S complete. After filling 6S, then 1D, complete 4F, then after that we come to 5D. This means filling first this, second this, and third this. The last electron goes to D. So it's a D block. Same, first filled this, next this. The last electron we have filled in D. So it's a D. First this, next this. Last electron goes to D. But in this case, the last electron goes to S. 3 questions solved from the modern periodic table. Right? More questions. Now the question is, an element is atomic number is 106. What is the name of the atomic? What is the name of the element? And write the configuration. There are so many configurations given. First of all, we write ourselves, then I will give you the options. You know, in this case, you know the configuration method is always electron goes to 1s first, then 2s, then 2p, then 3s, 3p, 4s. This all I have explained to you. 4s, 3d, 4p, 5s. After that there is a 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5d, 6d, 7p. This is a pattern, please remember. Now, one is helium 2, neon 10, argon 18, xenon 54, krypton 36, xenon 54, radon 86. Now, dear children, always write 2s, 3s, 4s, 5s, 6s. Each and everything I have already explained you. Now your question is 106. 106 means we are very near to radon 86. Write down. It's a radon 86, 7s, 7s2. Now come to this 7s2. After that there is a 5f. 7s2, 5f, 14. So it becomes 86 plus 2, 88. 88 plus 14, 102. After that, we have filled 7s, we have filled 5f, and the value is of 6d. Now what left will go to 6d. So it is 88, 88 plus 14, 102, and left with 4. So it's the right answer. Now let me check the options now. And what's the name? 1 for un, 0 for nil, 6 for hex, and end में in. So we say un, nil, hexilum. Now let us check the options. Write down the options of these questions are. The options are, it's a radon 5F14, radon 5F14, a 6D4, 7S2, first option. Second option is given, radon, it is your 5F14, 6 5F14, 6D5, 6D5 and 7S2. Third option is 5F14, 6D6, 5F14, 6D6, 7S0. The fourth is 5F14, fourth option, again a radon, 5F14, next is 6D1, 7S2, 7P3. What you have done? You have written your configuration by the help of that ladder diagram. After you can match your this configuration matches with the first option, 7S2, 6D14, 6D4 and 5F14. Your correct answer is 1. Okay, so in this way, for writing electronic configuration, you may take the help of the ladder energy level diagram that I have taken just now. Now I am taking more questions from the modern periodic table. And the question is, an element is placed in the 7th period. The question is, an element is in the 7th period. 7th period it is. An element is in the 7th period and it is in the 10th group. 7th period, 10th group. 7th period, 10th group. The question is, write the IUPAC name of the element. What is the IUPAC name of the element? Will be. Its names what will be, because we don't know the name of where it 7th period and 10th group. Do you know what the 10th group is? You know the 10th group 1 to 2 in the S block, and after that 3 to 12 in the D block. Groups 13 to 18 groups are in the P block. This means your 12 is in the D block. It is again in the 11. Your 11 group is in the D block. Your 10 group is in the D block. Now what you will do, students, this is your 4th period. You know, D block started from the 4th period. And this is your 3D series. 3D series. Now you can check in the 3D series, this is your last element, started from zinc, started from scandium and up to zinc. And its number is 30. I told you 21 to 30. So its atomic number is 30. That means it is 29 and it is 28. It is 28. Now what you will do? So in the 7th period, what I told you just because in the just now I have given you one atomic number. You may check those atomic number. So here it is that's 28 to 28. This is 3D series. After that this is 4D series, 5D series, and your element belongs to 6D series. Why? Because your 3D series in the 4th period, your 4D series in the 5th period, your 5D series in the 6th period, and your this series, your 7th period, has 6D series. Do you know the 6th period of the D block? 6D started from actinium. I told you actinium AC, and it's 89, 90 to 103. 90 to 103 goes to F block, and after that it's 104 second, and 105 third, 106 fourth, 107. This is your group number 3, group number 4, group number 5, group number 6, group number 7, and same group number 8, group number 9, group number 10. So your element is 110, 110. It's an unylium, and the 4 options are given. One is nil septium, nil nilium, nil bium, none. Your answer is 1, So what is 110? It's unnillium. So your correct answer is unnillium. So dear children, this is my request to all of you, kindly learn all the atomic numbers, starter and the end. I think you might have written starter and the end. S block, P block, D block, F block, starter and the end. Now the question is, next MCQ, there is a last configuration is 4S1, it is given 1S2, 2S2, 2P6, 2P6, 3S2, 3P6, 3P6, 3D10 and 4S1. This is a configuration given, and the question asked is what is the atomic number of the last element of the same group which is recently discovered. What is the atomic number of the last element of the same group? That is the last element of the same group. Do you not say 4S1? It's exceptional configuration. The element which is of 4S1, that means it is atomic number is second last. Now again coming to the D block. D block started from 21 to 30. If it is 30, it is 4S2. That means this is your 29. Atomic number 29. This element belongs to 11. Its group number is 11. Second last. 21 to 30. D block started from 21 and up to 30. 30 is 4S2 3D10. 29 is 4S1 3D10. So this is 4S1 3D29. Second last. It is the second last element, D9. The configuration is. It's a second last element. Now, you know, again listen. No, it's the last element. Last element is, now you will again check. The first started from 21 to 30. After that there is your, this is 29 and your seventh period, coming to the seventh period. Because asking about the last element. Seventh period again started from your AC, started 89, 90 to 103 is in the F block, 104, then 105, 106. These are all your D block. 107, 108, 109, 110, 111 and then 113 to 118 is in the P block, 112. So this is your D1, D2, D3, D4, D5, D6, D7, D8, D9, 1, 1, 1. So your answer is 20 atomic number. Atomic number 119, atomic number 111, none. Your answer is 111. I think understand or not. So they are asking about the last element of the same group. Last element of the 29 group is 111, D9. So now from these questions you came to know that the atomic number, you must learn the starter and the last element. Starter and the last of each of the group, that is S block, P block, D block and F block. So this is all about your modern periodic table. Many of the questions I have already taken. I'm taking periodic properties. Periodic properties. The first periodic property I am taking is atomic radius, atomic size. So I am giving you 3-4 points. You know, size decreases in a period and size increases in a group always. But there are few exceptions. To write down, exceptions are decreases in a period and increases in a group. Always remember, greater the positive charge, smaller the size, greater the negative charge, larger the size. One more, now write down few points. Greater the positive charge, aluminum 3 plus, smaller than Mg2 plus, smaller than Na plus, smaller than neon, smaller than your F minus, smaller than O2 minus, smaller than N3 minus. Very best point, it's isoelectronic species, means same number of electron. Remember, greater the positive charge, smaller the size, greater the negative charge, larger the size. Write down this. The second is, now there is a D block, 3D, 4D, 5D and 6D. Always remember, size increases in a group. Size increases in a group, but always note down due to lengthanoid contraction, that will come in class +2. Due to lengthanoid contraction, size of the 5D is approximately equal to 4D. So 3D smaller than 4D, approximately equal to 5D. Kindly note down it. So this is the third point. First is atomic size decreases in a period because of the increase in the nuclear charge in a period. Atomic size increases in a group. Second is greater the positive charge, smaller the size, greater the negative charge, and larger. Third point is 3D, 4D, 5D. Due to lengthanoid contraction, the size of the 5D decreases. Detail I will take in class 12th. What do you write down? 3D is smaller than 4D. It's approximately equal to 5D. Exceptional case. Next is last point left in atomic size. And now other properties I will take in the next lecture. Next is, there is a P block. In the P block is a boron family. Boron, aluminium, gallium, indium, and thallium. Kindly note down, size increases in a group. Size increases in a group, but always remember gallium has a smaller size than aluminium. Exceptional. Due to poor shielding of d electron. Detail why gallium size is less than aluminium. Later on I will tell you when I will take in detail regarding the chapter. This is your P block. Size of the gallium is smaller than aluminium. It is your next is carbon family, carbon, silicon, germanium, stainless, and lead. Size increases in a group, but germanium size is less than silicon. So write down about the sizes. There are the 2 points. Size always increases in a period, increases in a group, and decreases in a, that is called period. But there are few exceptions. 3 exception points I have shared with you. Size of the 5D equal to 4D. Size of gallium is less than aluminium. Size of germanium is less than silicon because of the poor shielding of the d electron. Otherwise, size always decreases in a period. And there are 3 types of sizes: covalent, van der Waals, metallic. Remember, van der Waals radius shown by noble gases. Van der Waals radius is always greater than metallic radius shown by metals, and after that covalent radius. Covalent radius. So this is size is order. Van der Waals radius is shown by noble gases and the non-polar. So it's van der Waals radius, which is the greatest one, and then metallic radius, and then covalent radius. So I shared with you 2 topics. The one was the modern periodic table, and the second is your this is atomic size. You know what is atomic size? Detail, what is it? You will take in chapter, when the detail of the chapter will be there. It is the most probable distance from the nucleus up to the valence electron. So this is your property, atomic size. So I think now you can take the questions of atomic sizes as well as other periodic property in my next lecture. Kindly go through 2 topics. Your 2 topics from the periodic table covered today. The one topic is modern periodic table, and the second is your periodic property number 1 is atomic size. So other properties, ionization, potential, and electron gain enthalpy, I will take in my next lecture. Thank you.